So let me close down what we were doing with the bash command injection. And now we're going to go on to SQL injection challenges. So for people that don't know or never heard of SQL before, SQL stands for Structured Query Language. It is used for database administration. Basically, the way that you would interact with a database is you would send it a query, a structured query, you might even say, to grab data or update data within a database. And luckily, we have a place right here to practice. So here we have a database, and we can click here to reset the database because someone might have changed it. And what we can do is we can run straight SQL commands right here in this query box. So if we run show databases, we should, this is a full SQL command that will tell us what databases are available on this server. And so we have information schema database and widgets database. And now we can use show tables to figure out what tables are in those databases. And if we run that, we see there is tables in widgets. We have employees. So there's a widgets.employees table. And that contains data about all the employees on in our database. So let's look at the select command. When you are grabbing data from a database, the primary command you are going to be using is called select. And so we can see some example select commands being used here. So if you want to select just a static variable or a static item, you can, for example, select the number 1. And that will return a 1. We can also select a string, such as this is a string. And that will return a static string. And that's not particularly used. No one would ever use SQL for that. What you would use SQL for is for going into a database and grabbing data. So we could, for example, grab all the data from the employees table. So let's select star from employees. And this is going to dump the employees table. Here we go. Here's some real data in the database. So the employees table consists of an ID, a name, and a social security number. So we have the ID 1, the name is Bill Gates, and the social security number is 111223333. So on and so forth. Another useful command is the substring command, which will which will cut up a string essentially. So here we have so we're starting at character 2 and 2 characters long. So we get a substring starting at character 2, so 1, 2, E, 2 characters long, E, A. And if we were to change that to 2, 3, we should get EAN. Submit, EAN, there we go. Another useful SQL command that you're going to be using a lot with SQL injection is concat or concatenation. So we're going to put 2 strings together into 1. And you'll understand why that's useful in a bit. So if we have 2 strings, peanut and butter, we can concat them into peanut butter. There we go. We have put 2 strings together into 1. Now we have peanut butter. If you only want to select one item, so if we look again at the employees table, there's a bunch of data here. So we can select an ID, a name, or a social security number. Let's say we only want the name. We can select name from employees. So instead of an ID, we're actually going to select the name from employees. There we go. So now we selected only the names from the employees table. If we want to select the name and let's say their social security number, we would do select name, comma, SSN from employees. So now we have the name and social security number. And we can put that, remember I said the concat function is useful. We can use that to concat values within our select statement. So we can put the name and ID in one value from the employee table. And we're going to select, so how am I going to explain? So there's a where clause here. So we're going to select the name and ID, put that in one field from the employee tables, but only, and that's where the where clause comes in, only where ID equals 1. So we're only going to select the first one item from the employees table, and that should be Bill Gates. There we go. So we have Gates 1. So we put the ID and the name in one field. And that might be more useful in an actual SQL injection if instead of the ID, we were to put the social security number and the name. There we go. So now we have Bill Gates and the social security number all in one. And the other thing to note, remember when we ran the show databases command, we saw that there was something called information schema. That information schema is really useful to us because it contains metadata about the database. And we can use that data to gather information about how the database is structured and what is in the database. So if we ran this command, select table name from information schema.tables, we should be able to find, all the tables, and there's our employees. So we know that there is a table in our database called employees. So that information schema table, and it is in every SQL or in every MySQL database, and it will contain information that you will need to perform SQL injection. All right, so on a normal website, no developer would ever let you put straight queries into the SQL database. That would be a huge mistake. Where we run into issues is you have a template. For example, like let's say, remember this statement here, select star from employees. You might have, or even better, where ID equals 1. You might have a template here where ID equals something and you have the user input the ID. So you might say ID equals 2. Okay, that's fine. Or ID equals 1. And then you can start injecting SQL from this point onward. And that's where we're going to start doing our SQL injection. So here we have an example of this. So if we have, let's put in we have a name and a submit button here. So if we're going to if we put in the name Bill Gates, and this should be a similar database, we ran this query. We said, select the name from the employees table where the name equals Bill Gates. And we got our name back. Awesome. If we do another name here, like Tip O'Neill, those of you young enough to remember who that is, a politician, we're going to run into some errors. It says, you have an error in your SQL syntax. What happened? Well, let's look at the SQL query again. We have select name from employees where name equals Tip O'Neill. Well, notice how names go in single quotes here. So what happens is that the SQL query read this and it said select name from employees where name equals Tip O, and then read this Neil part as part of the original SQL query. So that means we can inject stuff. So that single quote messing up the entire, giving us an error, means that we have SQL injection.
Okay,
we can start.
Try zooming in a bit. Someone's complaining about the resolution of the video, so making bigger fonts would help.
All right, let's see if I can't also shrink the screen a little bit. Does that help?
Yeah, that looks better.
There we go. There we go. So we select the name from employees where name equals Tip O, and then we have Neil. So this is part of the SQL language. So if we wanted to, for example, have this execute correctly without any errors, what we would have to do is add a comment after this. So this pound symbol, this hashtag, if you're a bit younger, means that the rest of this statement is now a comment. So what would happen is that we would run this query here and ignore the rest. So it looks for Tip O. Tip O is not in the database, so we get no answer. If we wanted to, for example, let's run this query right here, Sam or 1 equals 1. What are we running here? So we select the name from the employee tables where the name equals Sam or 1 equals 1. Well, this is always true. So we're going to select all the names of the employees table because we're always going to, our where clause is always going to be true. So now we know all the names in the employees table. So how do we select more than just the names? Because the names are nice, but we want some social security numbers. That's where the union select comes in. So this is our bag of tricks right here. The union statement allows us to do another select statement with our original statement. So if we do Sam, single quote, union select 1, we're going to select a name from employee where name equals Sam. So there's no Sam name, but we're going to select a 1. Okay. Now the thing about the union select is that it has to return the same number of columns as the original select statement. So this select statement selects the name. So you can't select the name and the social security number, but we could select the SSN. And let's see what happens here. SSN not in field list. So let's do this entire select SSN from employees, like so. We're going to just copy that, go back. We're going to select the social security number from the employees table. Let's see what happens. Aha, now we have some social security numbers dropped from our database. So we selected so the original query is here. And then here's where we were able to inject our own code. So we injected Sam and then a single quote, and then we selected all the social security numbers from all the employees. If we were to try to select the names, social security number and name from employees, it's not going to work. It's going to give us an error. So the select statement used a different number of columns. So like I said, the union statement needs to have the same number of columns as the original statement. So remember when I said that the concat statement, the concat function was going to be really useful? Here we go. So we're going to run the concat we're going to concat SSN and name. In fact, let's make it even a little easier. There's SSN, a space, and the name from employees. Let's see what happens now. There we go. Now we have a much more interesting and organized data from our database. So we were able to select 2 items, put into a single column using the concat statement, and return all and dump the entire database with everybody's social security numbers. So the first flag is to find Linus's social security number, and then the second, and we already did that. So the second flag is to find Steve Jobs' password. And that is going to be in a different table. So you're going to have to start looking at the information schema table to find all the tables and databases that are on this server. And let's see, we're going to run. Okay, so the next step, so far we've been doing everything manually. And for these simple exercises, that's fine. But when you start getting into the real world and you start doing real SQL injection, this can get tedious very fast, especially when you're dealing with lots of different types of databases, lots of different types of injections. You don't want to do everything by hand all the time. If you can, you want to automate the process. And this is where SQLMap comes in. So SQLMap essentially is a SQL injection automator. And it should already be on my computer. So if I run SQLMap, yep, there it is. So SQLMap is already on my system. So in order to run SQLMap, what we're going to do is we're going to you could run SQLMap -- help and look at the command line, but actually for SQLMap, because it's such a command line and parameter heavy application, I like to look at the SQLMap usage page from their GitHub. And this will tell us how to use SQLMap. So the first thing you do is you select -u and the URL of the site that you're trying to do SQL injection on. So in this case, the challenge is for this page right here, challenge2.php. So for people that don't do a lot of web development, at the end of a URL, you might have a question mark, and those are your parameters to your page. In this case, we have a U parameter that is vulnerable to SQL injection. So we're going to copy this, Control-C, and we are going to run SQLMap -u and then the URL. And that'll tell us if it's vulnerable, which it is. And there we go. So we have, it already said it's vulnerable. I ran this before. So SQLMap keeps a cache of all the vulnerable sites that you run it against, so it knows what to do. That's why it ran so fast. When you run this, it's going to ask to, do you want to try these commands? Do you want to try that? And you'll just say yes or no and get through it. So next, okay, so we know it can run. Now we have to do something interesting with SQLMap. So once again, we're going to go back to the usage page here. And we're going to, let's say we want to dump the database. Dump all, there we go. So we're going to -- dump all. And this is a very common usage of SQLMap, is to simply just dump all the contents of the database and grab all the data. So -u, the URL, -- dump all. There we go. It's going to run SQL injection on this page and then dump everything, and it looks terrible in this low resolution, but we should have, there we go. Aha, looks like we got everything. Oh, it's grabbing a lot of stuff from the database. And this is running a bit longer than I was hoping it would run. Let's do something a bit less unwieldy. So let's just try to dump the databases. So let's see. Let's dump the DBS. So here we go. Let's enumerate the databases. SQLMap -- DBS. There we go. So now we know the databases in this in this MySQL server. There's a widgets2 database. All right. So now, once again, we look at the usage. We can so ~D and the DB tells us which database to use. So we're going to use the widgets2 database. And now let's just let's grab all the tables. So in order to do that, we go to the usage. We're going to do -- tables. Now we're going to look at all the tables in the widgets2 database. So we have an employees table and a passwords table. All right, now we're going to select the passwords table. And yes, and then -- dump, I believe. Yep. That should give us the passwords table. Yes, there we go. So the 3 different passwords are password, Alpine, and Circus. And I think I actually did the harder of the injections challenges. So let's see. The first challenge, we're going to find Steve Jobs' social security number. Is the number, let's see, use SQLMap on the target. The flag is the number indicating the highest privileged user. Explore the tables. Okay. So you're just going to explore the databases using SQLMap. So far, we've been able to dump data directly using SQL. So we run a SQL command and we get output directly from the server. Sometimes we're not so lucky. Sometimes a SQL command is running behind the scenes, and all we know is that we can inject something, but we don't get any direct output. So let's look at an example of this right here. So if we have a names input box here and a submit button. So if we try to search for Bill Gates, we get something similar to before, where we see our query and we see Bill Gates is found. But instead of this coming from the database, this name is actually coming from our input. So if we were to search for X, we get nothing. But what we can do here is we can essentially play 20 questions, because what that means is that if we get a true result, so if where here is true, we get something written. Whereas if this where clause is false, we get nothing written. And so what we can do is play 20 questions to figure out what is in the database. So if we do this example here, X single quote or A equals A, so A equals A will always equal A, we're going to get true. So here we have a true statement found. So we know that this where clause was true. Now, if we wanted to find the length of the database, let's figure out what's going on here. So we could do X single quote or length database equals 1. Let's try that. It's not 1. Okay. So let's try 5. Let's see if the length is 5. No, it's not 5. Let's try 6. It's not 6. Let's try 7. Let's see if the length of the database is 7. Nope. But what if the length of the database were 8? Let's see what happens now. Aha! So we know that the length of the database is 8. And so in this blind SQL injection challenge, what you're doing is you are trying to, like I said, play 20 questions. So you can ask the server many yes or no questions over and over again. And using that yes or no response, you can figure out what is in the database. And so there's some challenges using blind SQL. So you're going to, so we did the first one already. We found the length of the database's name, which is 8. And now we're going to try to find the social security number. And there's some more blind SQL injection here where what we're doing is we're trying to find substrings. If we're finding out if the first letter is A, B, or C, for example, we can try that here. We can find out the length. And so now we have to find the first 3 digits of Bill Gates' social security number. We have to try to find the admin's ID using those same hints, and so on and so forth. And I can almost assure you that if you want to cheat on this, SQLMap will work on this input as well. So if you want to try to use SQLMap to do the blind SQL injection, that's also doable as well, although you won't learn by hand. So just keep that in mind. Though usually when I do blind SQL injection, I'm almost always using SQLMap because while this one does give a kind of an instant yes or no response, a lot of the time when you're doing SQL injection, you're doing things like a side channel attack where you get no output whatsoever, but you can hang the server for like 2 seconds if it's yes, or make it immediately give a response if it's no. And so you essentially just have to end up scripting things out anyway. So anyway, that's it for this section on SQL. If you have any questions, let us know.
So good. I've got a question in chat asking about the reasons behind these things. So let me put up this video and then maybe we should address that. I'm going to stop this recording.